Alright, so next we're going to talk about combining rational expressions, and to begin I just want to remind you, when we talk about rational numbers like the 3/5 and 1/2 in the earlier video, how did we combine those? How did we add, subtract, multiply, divide? Well, if you need to review that, make sure you do. I'm going to jump right in and into some examples. Okay, so it says simplify each expression and note restricted values. So now the restricted values are actually going to come from whatever makes any denominator equal to 0, and I mean any denominator. So in this first one, the restricted values are going to be x cannot equal 2 and -1. Okay, so just keep that off to the side, and then we'll use that later when we're solving rational equations. But anyway, we're going to subtract these things. So we need a common denominator, right? So I need to multiply this first part by x plus 1 in both numerator and denominator. And the second one I need to multiply by x minus 2 to both numerator and denominator. Okay, so then in this first term I'm going to have x squared minus 1 times x plus 1 in the numerator, and then x minus 2, x plus 1 in the denominator. Okay, next term I'm going to have x minus 1 times x minus 2 rather, and then the denominator is going to be x plus 1 times x minus 2. Okay, and now from here we have to FOIL this all out. So this first term, I can say that this is going to be x cubed plus x squared minus x minus 1, and then x minus 2, x plus 1. Okay, and then now minus, let's see, this is going to be, after I FOIL it out, x squared minus 3x plus 2. Again, I did a little bit of math in my head there. Okay, and then the denominator, x plus 1, x minus 2. Okay, and I am really bad. I'm forgetting equal signs. Please forgive me. There we go. I got them in there eventually. And now the only thing that I would do is, I really like to have just one one denominator visible in my final answer. So I'm just going to write it as one denominator. But then I have to remember that I'm subtracting each of these. So this subtraction sign is going to distribute. That's the number one mistake students make. So I'm just going to say here, remember to distribute the negative. Okay, so key thing to remember, I'm going to have x cubed plus x squared minus x minus 1, and then minus x squared plus 3x minus 2 for that second term. And now I would just combine like terms as appropriate. So denominator remains untouched, and the numerator is going to be x cubed, and then the x squares are going to cancel, right? And then I have minus x plus 3x, so I have plus 2x in total, and then minus 1 minus 2 is minus 3. Okay, and I could go ahead and factor this. I believe it would factor, yep, this would factor as x minus 3 and x plus 1. This is a fun one, over x minus 2, x plus 1. And then at the end I would say, okay, well, there's a common factor, and I have my signs mixed up, and so in this case, even though I can factor, there isn't a common denominator. So I would be forced to leave it like this. Okay, so that would be my final answer. For the next one, I want you to pause the video and try it on your own, take a shot at it, and then resume when you're ready. Okay, and the restricted values, I actually want to make this into a quiz question. So x can equal what here? Okay, and you're going to answer that in a quiz. Okay, but from here on, we're just going to, again, factor first. So this ends up being what you will see next. So I paused the video and factored this, and here's what I got when I factored it. And next, I'm just going to multiply fractions, or multiply rational expressions, which is just multiply numerators and denominators. So I have 2x plus 3, x minus 4, and then x minus 3, x plus 2. Okay, and then x minus 3, x minus 4, okay, in the denominator. And now I would just cancel any common factors since I have multiplication throughout, and so the x minus, well, you get the idea. Okay, so the x minus 4s would cancel, and then the x minus 3s would cancel, so I'm left with just 2x plus 3, x plus 2, and for me, this sort of thing, this is totally okay. So don't worry about foiling it out. If you want to, hey, great. Alright, so that's that one, and again, the restricted values you answered in a quiz. Next, there's a whole bunch of problems here. I think I'm just going to let you work on these, and I will provide you the answers for the first two here, so the top row here, as it were. I'll provide you answers here in a moment, and then after, we will focus on the lower two questions. And so here I just gave you the answers. Again, you need to provide the work. Now, with something like these bottom two, these are exercises that students look at and kind of have a little bit of freak out moment. And I understand they're not the funnest problems to work through. But what I encourage students to do is, when they see something like this, break it into pieces. So let's break it into pieces. I'm going to do the numerator first. I'm going to do that work over on the side, and then subsequently, I'm going to do the denominator off in a different region. And then, again, I'll combine them, okay? But let's focus on one problem at a time. So let's look at the numerator. If I look at 3 over x plus 1 plus x over 3, that's easier for me to work with, because all I know I have to do is find a common denominator and add them. So, again, pause the video and skip this if you and do the work if you need to. I get 9 plus x squared. X squared plus x after I simplify that, and then 3x plus 1 in the denominator. Okay, so that one's there. And then when I look at the denominator here, when I look at 2 minus 1 over x, now this is really confusing, because how do you take a number minus this? Well, remember, every natural number is actually a number where there's a denominator of 1. So this is easier for me to work with. All I have to do is multiply by x and x to numerator and denominator in that first term. And so I end up with 2x minus 1 all over x in the denominator. Okay, now what I'm going to do is come back to the original equation, and just remember that this vertical bar, or this horizontal bar, is the same as division. So I'm going to write this as parentheses 9 plus x squared plus x all over 3x plus 1, and then divided by, now, parentheses 2x minus 1 over x, which was the bottom, or the denominator, or the fraction in the denominator. Okay, so, and then now this I can work with. Okay, I can say, oh, well, this is the same as 9 plus x squared plus x all over 3 times x plus 1, and then times the reciprocal, so x over 2x minus 1, and then now, okay, this is just the same as saying x times 9 plus x squared plus x all over 3x plus 1 times 2x minus 1. Okay, so that would be my final answer. I haven't talked about restricted values in any of the problems. The restricted values here are going to be x cannot equal, okay, let's see, any denominator, so x cannot equal -1, x can equal 0, right? And there's a bonus one, 1/2. Now the reason for the 1/2, and I'll back up and show you the other ones, but if we look carefully, this is going to be a denominator as well. It's going to be a denominator corresponding to right there, right? So the denominators, you have to look at the numerator of the denominator too when you have complex fractions like this. Backing up here, looking at restricted values here, a certainly cannot equal 2, but I think there ends up being another value that you can't have here, because again, you're dividing, so this numerator in the denominator, or the numerator of the second term here, is also another denominator, and here you end up getting 4 being another restricted value, as well as -2. So you end up with a few more restricted values in the case of division. Division, you always have to check this for restricted values as well. And then over here, -3. Okay. So now this next one, I want you to try it on your own and see what you get. As a push, here you go, you can represent the denominator as h over 1. So your job is going to be to combine the numerator first, kind of off to the side over here, and then this is already simplified, so you're going to end up saying that there's something, which you get from over here when you simplify the numerator, divided by h over 1, and then in your next step you'll have the same thing times 1 over h. And I think we'll check in on this at the beginning of class and see where we're at.